this again. Are you seeing the Polar Educator website?
Yes.
Okay, so I apologize for that.
Yes, we are.
There you go. Okay, this is the polareducators.org website. Sorry for that little glitch. Might want to write down this web address if you don't have it. And then the PEI vision statement. This is also on the website. And then questions for our presenters. If you have questions during the presentation, there's a question box on your control panel for GoToWebinar. Just type in your question there, and at the end of each of the presentations, we'll pose those questions to our presenters. And any questions that we don't have time to have answered tonight will be on the discussion group, which starts Wednesday, October 28th and goes till November 11th. We hope all of you will join in that discussion group. Again, it's polareducator.org. Notice there's not an S on the website, and /members will take you to that place on the website. Your presenters tonight. I have been lucky to have worked with both of our presenters for quite a few years now, approaching 10 years, I think, with Dr. Xavier, and Patricia and I have worked together for quite a few years too. We met each other during the International Polar Year. This picture that you see on your screen was the three of us in Germany together. So we've worked together on quite a few different projects, and I'm thrilled to be able to introduce them today. Our first presenter will be Dr. José Xavier. José is a researcher at the University of Coimbra in Portugal and also at the British Antarctic Survey. He's a marine biologist, Antarctic marine biologist, working with food webs from algae to top predators such as penguins, seals, and albatrosses. He also is very involved with the higher levels of science through the Scientific Committee on Antarctic Research, and has always been interested in education outreach, works closely with APEX, the Association of Polar Early Career Scientists, and also our organization, Polar Educators International. He also is involved with policymaking through the Antarctic Treaty Committee. Patricia is an educator who has worked closely with José for many years. She also is a fellow researcher from the University of Lisbon and is focusing on the promotion of science literacy for society and building strong relationships between scientific research and science education. So at this point, I'm going to turn the screen over to José, and he's going to do his presentation. José, do you have that?
Okay. Okay, are you going to send it to me, presumably?
AR. Okay, we're not seeing yours yet. There you go. Now we've got it.
Yeah, fantastic. So welcome. Welcome, everyone. It's a really big pleasure talking to you. I'd like to first, more than anything, thank Louise and Gary and all Polar Educators International for this initiative. It's really a big pleasure talking to all of you tonight, or today, or this morning, or in the middle of the night, wherever you are. It's a huge pleasure. So, as Louise mentioned, it's a huge pleasure talking to you. And just to complement what Louise just mentioned, we've been, as scientists, but I also feel that I'm an educator as well. Actually, I think we are just a huge combination of being a scientist, an educator, and a policymaker. It's a vision that we have for scientists that we've been working for quite a considerable time, particularly since the International Polar Year. And this is what I work on. I'm really interested on the role of the Antarctic food webs, how they work, how they function, how they deal with big issues like climate change or ocean acidification, between many other issues. And this particular question is what will happen to penguins. I will provide you some really good insights on what might happen to some of them. And all of this, of course, will come across on the evidence that we have towards, particularly on climate change, and how, when we have such a broad question like what will happen to penguins, as a scientist, we can't make things simple, so we have to say which species are we talking about, but we get into that anyway. So, so myself and Patricia welcome you to our seminar. So this is what I'm going to talk about. I'm going to just give an overview about what is happening in the world. There's still some arguments what you consider by climate change. Don't forget that weather and climate changes every day, changes every hour, changes every second. When we're talking about climate change is when we start having, out of the normal change of the weather patterns or the climate in this case, it becomes not normal anymore. So if you, for example, if you live in New Jersey and you are used to temperatures of 70 degrees Fahrenheit, for example, and within, imagine that on average you'd have those temperatures in the last 30 years, but in the last 10 or 15 or more, you start to see a big drift of warming, for example. And usually when we talk about climate change, we're talking about decades of change, not just short-term. So usually, for example, in the Antarctic, we're talking about a good data series, so a huge amount of data when we're talking about more than 50 years, for example. And also, just in terms of the climate changing, I also will approach what is happening, in particular in the Antarctic, to give an overview what is happening there, and then we talk about the penguins and how we foresee in the future, because we have such a big questions as you learn in these coming few minutes, how the Antarctic is changing, how the world is changing, and how we've been using penguins to explain how animals are able to adapt. And like us, humans, according to the change of the climate, with probably a potential increase of storms, for example, or sea level rising, one of the issues is how well we're going to adapt, or how we're going to do it. And this happens also with the animals that live in the ocean. But one of the important things when we're talking about the Antarctic or the polar regions, and that's why Polar Educators International is so important, is to how can you make the science that we're discovering to the rest of the world and to the youngest generations. One thing that we have to have in mind immediately is that policymakers, the general public, is highly interested in what we're discovering really far away. We're dealing with climate change, acidification, sea level rising, issues that you hear every day and is in the news. People do care what the scientists are doing, and the schools also are also very interested in what we're doing. And we have very good examples within members of the Polar Educators International that uses issues like climate change or the animals like penguins that can be used to transmit big key notions and definitions of elementary and basic knowledge about the polar regions. But yes, the general public is interested what we're doing there in the Antarctic or in the Arctic. And the other thing, rather than or only just being interesting, is also fascinating. And this is the other concept that is really important when we talk about the polar regions. They're quite unique. They're very special. For example, me coming from Portugal, it's quite unique coming across images like this one. This was in my expedition in 2011, 2012 in Livingston Island. Huge icebergs, massive glaciers. We have a close contact with the animals, and it's something that's quite unique in the Antarctic, for example, is having a very close contact with the animals you're working with the penguins. So we have to handle them with very carefully, but we are in the middle of them, and it's very interesting to realize that such a huge part of the planet, and we're talking about 10% of our planet corresponds to the Antarctic continent and the Southern Ocean. These animals really live really far away, but for example, they're not afraid of you. And for example, this species, the chinstrap penguins, is one of the species that we're studying very carefully in the last few years, and we're still trying to understand how they are adapting to these changes of the marine environment. Other animals are like seals, for example. Again, not being afraid of us, we can get really close, and this is something not just as a scientist, but also as a human being very close to the fauna and flora is something quite unique that we witness, and is quite special. The other thing that is very unique about the Antarctic and the Arctic as well is that even the animals that live there, they are restricted to a highly demanding environment. So, for example, the sun stays around in the summer for 6 months, most of the time, usually between October and March in the Antarctic. So it's a long time, but most of the ocean or the food webs in the Southern Ocean really kicks off in October. So you spend 6 months of totally darkness, and then when the sun comes up, the ice starts to melt, and all the algae finally has the sun and the nutrients, and they reproduce very quickly. So all these algae that we call it phytoplankton blooms. So there's huge blooms of algae with the nutrients, with the sun. They reproduce really fast, and literally the food web kicks off because the plants are eaten by herbivorous organisms that eat the algae, and then you have fish, for example, or squid that eat those small organisms, usually are crustaceans, and then the squid and the fish and the krill, for example, are eaten by the top predators. So it's quite a unique environment that really waits it to kick off every beginning of spring, that usually is in September and October. So it's quite unique. The evidence that we have in terms of climate change is provided by numerous references. If you heard about the Intergovernmental Panel for Climate Change, is a group of scientists, and this book is widely available on the web. So if you go to Google, you can easily find it. And they provide evidence what is happening to the planet. But what I'm trying to show you here is two predictions for the future, and you have, well, one is for the predictions, but you could see that they tell you on the left, RCP 2.6 is one of the models they are predicted, assuming lower levels of impact of the environment, of climate change, and CP 8.5 is a more dramatic, so it's going to the other extreme. What changes will be higher in the future? So it's just two models, 2.6 and 8.5. So it's a different scenarios. So the 2.6 scenario, you can see that there's, if we start with the top one, when we talk about the average surface temperature, you could see with RCP 2.6, there's a little bit of just yellow and a bit of orange. But if you go to the worst scenario, the 8.5, you could see the surface temperature. There will be numerous regions that get much warmer, particularly in the Arctic, if you pay attention. The other thing that is quite worrying as well is in terms of the average precipitation. So how much do you rain? So it's not just the temperatures of warming, but also other factors. Other than these ones, the average precipitation or temperature could, like we heard about in the news as well, like for example storms or sea level rising. But again, if you go for the average precipitation, you could see for in the worst scenario there will be various regions that will get much more rain, or in the Antarctic much more snow than expected. So this is just to give you an insight that even the lowest predictions, the model of 2.6, the RCP 2.6, you could see that in terms of surface temperature or the average precipitation, there's definitely an increase, even if in slightly. And in the worst scenario, things will get dramatically warmer and will be more rainier in certain parts of the planet. So changes are likely to happen in the future. One of our most recent works, carried out by Julian Good, he's German. He led this work in our group. This is us, our group. They worked together in a recent workshop in Barcelona, and you could see on the left in red where there's a high concentration of color in red. It's around Antarctic Peninsula, and this figure on the left literally just shows you the agglomeration of factors that contribute to change in the Antarctic. And you could see these are the observed changes of today. So this is what we know today, what is happening today. And this is quite well known. It's been in the news that Antarctic Peninsula has been suffering a lot by climate change and a wide range of factors. And factors could be sea surface temperature increases, could be sea ice changes, could be more UV radiation, and so on. So it's numerous factors that contribute to climate change. But on the right, those are the future projections, what might happen in the future. And this is why it becomes quite important, this study, because you could see that by 5 factors, so a combination of factors that can cause or increase and promote more stress in the marine environment, you could see that these stresses in darker blue is not restricted just to Antarctic Peninsula, but it has been expanding to all around Antarctica. And this is quite concerning because instead of concentrating itself all the impacts mostly around Antarctic Peninsula, it means that in the future it's very likely that the impact will be spreading around the Antarctic continent on the coastal areas. And for example, if those stress factors are around Antarctic on the coastlines, that's where all the ice shelves are. So if the ice shelves, for example, the ice starts accelerating into the ocean, where these areas of stress increases. More stress means more changes of the ice, for example. It means that probably the ice shelves could start sliding more into the water and could promote an increase of sea level rising. So this is what we not only we have the data on the left, what it tells us today, and what we predict in the future. So more changes is likely to happen in the future. We already some evidence also on various examples, like the Larsen B ice shelf that you probably hear, as you can see on the right, and you could see that changes on these ice shelves has been breaking out from the continent as increasing in the most recent couple of decades, and this has been spreading to other ice shelves around Antarctic Peninsula. So we have very good evidence that this is happening and is increasing gradually through the years. And this is quite concerning, and this is what I want to show. If the sea level rising increases, this could impact very likely all the cities and the countries that are very coastal. And even today, we have several islands already disappeared by sea level rising, not only by the sea level rising by incorporation of more ice into the water, so that increases the sea level rising, but also by climate change, by the expansion of the water itself, that promotes that increasing of the sea level. And if, for example, if Antarctica would, for example, melted in totally, we're talking about a huge, massive increase of 60 meters, which is very unlikely, because although we have some signs, as I showed you in the previous slide, there's changes around Antarctica, the Antarctic continent. We're talking about very small numbers at the moment. We don't know what will happen in the coming decades, but not at as big a level. But if we went to a dramatic circumstances in the coming centuries, we're talking, if all the melted ice melted in the Antarctic, we're talking about definitely an increase of meters. And we have some also evidence, as you could see here on the left, you could see that areas of the continental shelf that have been covered by ice sheets before 1994, and now they're gone. So you could see that it's not just around the Antarctic Peninsula that we knew already, but also some signs already around Antarctica. So that carry goes along with our predictions might happen in the future. And one thing that is worth mentioning, and this is what I want to show you with a figure on the right, is that we're talking about 3 to 5 kilometers of ice that Antarctica holds inland. So it's a huge amount of ice and snow retained above sea level that, if it compares to the ocean, might have a major impact. And this is what I studied. I studied Antarctic food webs. I really want to understand how these different animals cope with environmental change. Could be seasonal change, interannual change, decadal change, could be whatever change you want to call it, so that we are quite open-minded as scientists, whatever you want to call it. But if there's any change in the marine environment, how these animals cope with it, how algae, that we call it as known as phytoplankton, how they cope with it, how krill, Antarctic krill, one of those important elements of the Antarctic food web, how they are able to change with if the waters get warmer, and how do the penguins, which is the theme of this talk, how they are able to cope with it. This is something I want to approach. One thing that Louise asked me was, how can we incorporate one of the key things that we find it truly important as a scientist, as a non-English speaker, not native English speaker, is how we have to be aware that if we're talking about, if we're expressing ourselves in the English language, how we have to be very careful of avoiding phrases that other people that are not English-speaking natives won't understand. So, for example, if you see a figure like this, that you have polar bears grabbing a bunch of penguins, in practice that won't happen, because, as you know, polar bears literally are in the Arctic and the penguins in the Antarctic. You'd have very, very regularly a native English speaker, you would say you're talking rubbish, which means that that's a nonsense, that makes any sense at all. But there's a lot of phrases that we have to, particularly when we're giving presentations, to be aware that we have to be very sensitive to the broader audience, that they don't have these kind of typical phrases that only native English speakers know. So we're going through the talk. You'll see some of the phrases that I came out about, but probably Gary or Louise or Betsy would like to comment and say that's a funny one, or that doesn't make any sense. I did try it though. I'm giving my best chance. And this is what we're witnessing today. This is what we know happening. This is the evidence that we have today in terms of the science. What's been happening to the Antarctic Ocean, so the Southern Ocean. We know that overall has been warming and it's getting more fresher. We know that frontal systems are moving polewards. Frontal systems are waters. A frontal system is where the warm waters coming from the north clash with the cold waters from the Antarctic. And where they clash, it's a region where the changes of temperatures are very dramatic in an area of kilometers. So changes of temperatures can go from 2 degrees to degrees Celsius of the temperature of the water to 10 degrees. So that's what we call a frontal system that could avoid, for example, the expansion and distribution of organisms that live in the Antarctic northwards, for example. So that's why it's really important. And we know that those, as the planet's warming up, those fronts are moving closer to the continent. We also been witnessing changes in the sea ice. Sea ice are quite important because if the ice is not as abundant, all the algae that are underneath that is waiting for the ice to melt, for the sun to come and for them to reproduce, if there's no ice, there will be less algae to reproduce, and less algae, there will be less animals feeding on the algae and so on. So have a knock-on effect on the food webs. And we know there's major changes in the sea ice, and also major differences between around the regions. So all these are all physical parameters. So like the water changes, sea ice, them warming, and so on. So what is likely to happen? What will happen to the animals? We know that these animals, particularly as like organisms like small crustaceans, they are following this warming, so they're getting closer to the continents. So we know they're moving more southwards. The Antarctic krill is also trying to adapt and coping with temperature, but different results. We don't know how dependent are they, Antarctic krill or fish, depend on the species. How dependent are they on temperature? Some are able to cope, others might behave differently. And the marine mammals, we still don't know. We have some evidence. One of my recent studies show that gray-headed albatrosses do try to adapt, but they don't do it very well, which is quite a surprise, because if some parts of the Southern Ocean is not working, some of these animals do try to adapt, but they are not able to. We thought if they weren't able to find fish, they would find squid or crustaceans in an efficient way to feed their chicks. But we have a mixed results here, and we find that some of them, at least some of the albatrosses, are not coping well. And the other issue that we heard quite a lot is ocean acidification. Ocean acidification is a process that, with more carbon dioxide in the air, is absorbed by the ocean and allows the process of the water become more acidic. So if it becomes more acid, we still don't know for the Southern Ocean what might happen in the future. We have some witnessing that some of the organisms are not able to cope very well, particularly the ones that have shelves, because if the water gets more acid, they might not be able to cope. This is one of the examples that we have here, that you can see on the top right, that you have a shelf of an organism that you can see from as the days go along, you could see how the shelf gets affected. The other example is that shows that it will be a deficit of iron carbonate in the Southern Ocean. So this is quite important, because iron carbonate is quite important for the algae to produce their own shells. There's some species of algae that need shells. So if there's a deficit of the material, the carbonate, the iron carbonate, for them to produce their own shells, so even the algae will be struggling. And this is a prediction that that Orr et al. In 2005 predicted for the Southern Ocean, simply because it absorbs more CO2 in the ocean, becomes more acidic, and has this knock-on effect on our carbonate. Another experiment with krill, with Antarctic krill, and this is the graph that you could see in the middle. that is the hatch rate. So many eggs hatch according to a different treatment. So in a general way is that the more acidic the water is, the less levels of hatching will occur in Antarctic krill. Although we have to be very critical with these results, in the sense that these are animals that have been collected in the fields today, and they were put into these different environments. In the future, one thing that we want to do is to give other generations of krill. So this generation today are used to a certain level of acidity. So for example, if you put other eggs, let them hatch, and put them in a more acidic environment, but slowly, and that next generation put them again in more acidic, to see how slowly by generation we're able to adapt, possibly the results might be different. This is what the work people have been doing, not only on krill but on the other organisms, to really understand the impact of ocean acidification. So there's still a lot of work to do, but Kagauchi really emphasized that if the ocean acidification increased immediately, they have probably a major impact on the hatch rate of krill. We know there's different species of penguins that are decreasing their populations. It could be a factor of being unable to cope with climate change, and you could see how for example, macaroni penguins have been decreasing. This is one of the populations we're working on, and you could see that they're declining simply because they are not able to find enough food when they're reproducing. So it's a sign that probably they are struggling. And when we're talking about penguins, we have to talk about how different penguins there are. And one thing that I think I have to introduce you is how long they've been around. So we have different species. So the first one have been here. The first one has been like quite old. 60 million years ago, there was we have fossils of something similar to a penguin. And then we have other ones. One of the massive ones, Ecodiptis selassie, that it had around 1.5 meters, so it's quite big compared with this Sphinxes ubolti, which the Humboldt penguin, which is we still have them today around in the Galapagos and in Peru. So you could see that 1.5 meters is quite a big penguin. So it's just to give you a sense of evolution. They've been around for quite a while. Others, the most recent, the ones that have been discovered, has been this one, Kairupu, that have been found. Their fossils have been found very recently, and they have an age of 25 million years, and in New Zealand. So they're quite big, 1.2 meters. And there's around 17 species of penguins around, from macaroni, different sizes, different shapes, if you call it. This is one of the chin straps. The gents is one of the species we're working on, and some of the biggest. This is the kings and the emperors. The emperors are massive and quite well known. Have you heard from Happy Feet, for example, the movies? And the range of penguins shift can go from really small ones like the blue penguins to some of the biggest ones that I'm going to show after. But one of the things that I have to tell you is, like you could hear on the right, Stacy with a Gentoo penguin. It's so easy to work with them. As I put it in a way that, again, coming back to the notion of how do we speak, and we have to be aware of a non-native speaker. How you hear easy peasy lemon squeezy to work with a Gentoo penguin is quite easy, and it's very easy. But if you know what it means that it's very easy to work with a Gentoo penguin. So these are generally some of the smaller penguins, and some of the largest ones. We have the king penguins. then are around 1 meter to the gigantic 1.2 meters of emperor penguins that is close to Jessica Meyer. And this is quite an important thing that I also to transmit to you, is that when we are teaching our younger generations, scientists, we also have men and women there. And I had a great pleasure to meet Jessica that work with emperor penguins. And now she's an astronaut, and it's something that is amazing to see how working in the Antarctic and used to these extreme environments can help you to other totally unexpected fields. And in this case, we had a huge pleasure to meet Jessica in one of the workshops that we had, and her being used to extreme environments in the Antarctic, working with penguins, actually helped her a lot on her new profession, and it's quite interesting. And we have macaroni penguins. They're talking about 18 million. So all you can see one penguin. If you come from the right, if you start from the right, you can see 1, 2 penguins. But all those little dots that you see on the left on the slope, all of them are penguins. So we're talking about here. We're talking about a colony of around 60,000 penguins. So the macaronis are and they also swim very fast. We're talking about, if you are wondering how much they would swim, if you think about it, talking about 20 kilometers per hour, 40 kilometers per hour. Just to give you an idea that the average Tour de France, when they're cycling in France, the average is 40 to 50 kilometers per hour, which is a huge speed. So for the penguins, is the Gentoo penguins that have been recorded as the most speedy ones. We're talking about 36 kilometers per hour. Probably Louise might know how much is that in miles per hour. Probably 30, 25, maybe. And I said it's spot on again, very Englishy. So these animals go really fast, very quick, highly adapted, and some of them might struggle. For example, the chin straps that I just show you here. So these ones are some that some populations are struggling. They live very close to the Antarctic, but they are struggling to a certain extent because they have nowhere to go. So if it's warming, their populations are getting steady but are decreasing slowly. But on the other hand, the Gentoo penguins are increasing in some of their populations, certain islands. So it's a kind of sign that some penguins are able to cope, others are not. And this is some of the recent studies from that are my colleagues from the British Antarctic Survey show that changes on the food web. So, for example, less krill or less ice, less krill will have a knock-on on the distribution of different animals, and in this case are contrasting that you have the chin strap penguins with these changes of the food webs have a knock-on effect on their populations and the distribution, so they've been reduced and constrained, whereas the Gentoo penguins are expanding, so they're able to cope with these changes and being able to either go deeper, further away, and they're able to find the food they want to feed their chicks and survive. And some of the work that we're doing is transforming that information into policy, and this is the work that we've been working on really hard with the Antarctic Treaty. And this coming year, we're going to have the celebrations of the Madrid Protocol. It's a protocol that argues that Antarctica should be for science and for peace, and should be for international cooperation. And in particularly environmental protection is some of the major goals that the Madrid Protocol has. And one of the work that we've been doing with the penguins is to trying to inform all the countries that are part of the Antarctic Treaty, which are more than 50 today, to be informed what we'll be discovering about the penguins and what can we do about them. How can we protect them? Or, for example, I give you one of the best examples. Imagine if there's a fishery that is catching Antarctic krill. One of the things that we need to know is to monitor the populations of penguins that live close to those fisheries, to know if they are impacted or not, and to know if they are high dependent on krill. If they are, how much can we provide guidance for the fisheries and the fishermen to know how much fish they should catch. One of the most recent that came out, talking about in the most recent weeks, is one paper by Stephen Chon in Nature that are changing the way we think about the Antarctic biodiversity. So the way we think about the different forms of life that we have in the Antarctic. And we just find out that is more extensive than we think it is more diverse than we think it is, and they are more structured and highly dispersed and distributed around the Antarctic in a way they haven't thought yet. So there's a lot of most recent information. And again, if you want to get some of these papers, do contact me or Louise or Gary or one of the committee members of the Polar Educators International, and I could facilitate and give you these papers. And this is really revolutionizing the way that we think about the science that we do. So if you want these papers, I can give it to you, and you can read about it, because these Nature papers are very easy to understand, and probably really important information that you can tell to your students. And if we look into the future, we had an horizon scan. So it's a group of scientists that got together and trying to find out the big questions that might happen in the future. And the questions that we came up with relates to a wide range of disciplines. You don't need to read all of this. You can read them in a leisure time. But this is just for you to have in mind that when we got this horizon scan and asked the Antarctic scientific community what are the biggest questions that we might have in the next 20 years, we came questions from space to oceans, to the human presence and the impact, to governance, to ice sheets and sea level. So wide range of disciplines when we're talking about those big questions in the future. And they came up with 6 priorities that we locked. If we start from the top, we're talking about the relevance of atmosphere and understanding how the ice sheet lost mass and how it's happening, the processes, the history of Antarctica, how much we can learn about the life, not only on land, but also particularly in the ocean, and the relevance of the universe. One of the questions that they had this year in this horizon scan is what will happen, or what happened in the first second after the Big Bang. And it seems that the Antarctic is one of the best places to come with some of these questions. And also, finally, to recognize and mitigate some of the influences and the impact that we have in the Antarctic. One of the examples that we have that actually is a great example for humankind was the depletion of the ozone, that the ozone hole actually is decreasing, and is a result of international diplomacy, but it was the discovery that we had in Antarctica, realizing the impact of these gases that affect the ozone hole, or the ozone levels. And to address all these big questions, we need funding, we need to access the Antarctic all year round with the right technology and a good sense of environmental protection with international collaboration. And this is why relevant I'm talking to you today, is because we have to address all these big issues. We really need to let these big messages to a wide range of publics. And this is a great paper that you could easily also read, and to really gives you an overview of what is happening in the Antarctic and why it's relevant to the rest of the world. So in a very straightforward way to reply to you what will happen to the penguins, as has been all through this talk, it depends on what species that we're talking about. We have, for example, the biggest penguins. The emperor penguins are not coping very well. The chin straps are not coping very well, for example. But for example, the gentoo penguins, they are coping it very well. So there's not a simple answer to that. It depends which species you're talking about. And now we're trying to understand what makes some species being able to cope with it and others not. And finally, my final slide, as I explained before, in terms of the science that we do today, English language is it is the language that we communicate in all the great majority of international conferences. And one of the challenges that we have today is how intimidating it can be if you're not an English native speaker. One of the things that I've learned is to keep our messages fairly simple. And what I've learned, I'm just giving you, if you're not an English native speaker, this is some of the tips and tricks that I learned all through these years when I'm dealing with the English language, particularly to get prepared to either talking to Skype calls to schools around the world, or in conferences, or even writing papers or producing reports. Learning English is relatively easy, I would say. Thank God it is, being a universal science language. But it can be quite intimidating when you're talking to conferences or writing papers. So one of the things that we do first is to approach the colleagues that are English native speakers and ask them how they do it. But also those that are not English native speakers, like your supervisor or your colleagues, educators from the other side of the planet, they are not from an English native country. And this can be quite useful. I give you an example on these talks. When I sent the slides today, last week to Louise actually reviewed them and made some corrections. So this is one of the examples how the team of PEI actually works. So thank you, Louise. The other thing that is very important is that English native speakers are quite happy to help. PEI has been an amazing network to actually develop our skills and be patient with us in how can we express ourselves better and better, and trying to avoid any slang or anything like that. One of the things that I do to get familiar with the English language is to, don't tell this to your children though, to watch movies or read books, or one of the things that is quite useful is to take a course. English course will help you a lot. And do join these webinars and ask questions real life, because it's a great opportunity for you to get familiar with the English language, or even organize your own webinars to get involved more in this. One of the tips that I do give to everyone, there's no easy solution to learn the English language. The best way to do it is to practice as much as you can, and be patient with yourself. You know, don't push it yourself too much, because you're human like everybody else. So everybody had to go through the same hurdles that you did. Just to finish it off, I'd like to, before I pass to Patricia, I'd like to thank Louise, Betsy, Betty, Patricia, Gary, and everyone from Pole Educators International for doing such a great work, and all my partners that have been working really hard, not only in terms of the science, but also in terms of the education and outreach that we've been doing for numerous years. That what we achieved in the last 10 years has been tremendous. So thank you very much for listening.
Jose, thank you very much. We have a few questions for you, so I'm going to pose a couple, and then we may have too many. We want to leave plenty of time for Patricia to be able to talk too. So I'm going to go back and just pose a couple of questions, if that's okay with you.
Sure.
Okay, so one of the questions, I had a couple of questions when you talked about factors that clump together, and several people asked the question, what causes the factors to clump together in some areas and not in others?
It's a very good, it's a very good question. Some of we don't know. I don't know why some areas will be more have a more deposition of factors. It could be just circumstances. Some regional areas. There's some areas that are more prone to, for example, to hold heat, or the currents, for example, that would allow you, or in this case, for the ocean, some part of the Antarctic Peninsula is quite well known to, with the currents, the way they flow, they might hold more heat, for example. So it's the circumstances and the characteristics of the different parts of Antarctica that might lead for them to hold more UV radiation or more heat that will allow to a collapse of ice shelves, for example, or just the currents that, for example, if you have stronger currents in certain regions, would allow them to the flux to be stronger, so have probably a more impact on the ice shelves. So it's literally the factors, the physical factors, from currents to heat to the characteristics of the environment.
Thanks. I'm going to ask maybe one more question, and then at the end, if we have time, we'll come back to some more. But one of the questions was, are krill fishermen impacting krill populations around Antarctica?
No, which is a good answer. Which is, in a nutshell, is that we are just catching less than 1% of krill. So the impact of fishermen on Antarctic krill is very, very small. And we have an organization, the Commission for the protection of the living resources of the Southern Ocean, which is called CAMLAR. This organization is very well regulating how much krill is caught every year. But at the moment, the interest is not that high, and the impact of the Antarctic krill is quite small by the fishermen. So at the moment, we don't need to worry too much. But we have this organization that has been vigilant and doing assessments every year.
Okay, great. If you want to go ahead and switch that screen to Patricia, we'll have Patricia do her presentation, and then if there are questions, if there's a little time at the end, we'll pose some more questions. Any questions that aren't answered tonight, we will post on during the discussion, and Jose and Patricia both will take part in that discussion.
Okay. I'm trying to. Okay. So shall I pass it to Patricia? Or?
Yes, please.
Okay.
Yes, go ahead and pass it to her.
Okay, here you are.
Okay, now.
Can you see my screen already?
Yeah.
Okay. Yep, we're seeing the screen. You're all set.
Let me see. Okay. So thanks to all of you for being here today. Good morning, good afternoon, or good night. I don't know. One of these will be correct. And thanks to PEI for the invitation to be here today. And thanks to Jose for all the interest in education and outreach, and for all work we have developed until now. For some of you, okay. For some of you, could be a little curious to see a Portuguese scientist and educators interested in polar science and polar regions. And apart from our strong historical navigations and discoveries and all the great Portuguese explorers, why are polar science and polar education so important to Portugal? We are a small country. We can see the little dot in red at the map. We are a small country, but half of our territory have coastline, so ocean and sea level is an important aspect for us. And furthermore, Some climate change consequences as storms, drought, water supplies, high temperatures are some of our concerns. And in addition, invasive species, habitat alteration, pollution, and ocean acidification are issues that we need to deal with. So we have made an effort to take part also in not only in the scientific level but also in diplomatic level to show that we are concerned about and what is happening, and we want to contribute to solve or minimize these issues and their impact. So Portugal is represented by José Xavier in Antarctic Treaty, and not in a diplomatic level, but in a scientific level in the Arctic region by João Canário in IASC. In my case, the first contact that I have with polar science and polar regions was during the last WPY, as Luis have mentioned at the beginning. At this time I was a science teacher and I have participated with my students in Latitude 60, the Portuguese educational project from WPY. And after I went to Oslo conference in 2010 and then Montreal conference in 2012. And there I had the proud to take part in the world of PEI and to keep contributing to its growth. And at the same time, I started to collaborate with the Portuguese Polar Program, ProPolar, on its educational projects that I will present now. In the last 2 years, we had developed two main projects. The Profession Polar Scientist, this one, which aimed to put teachers and scientists working together. And the other project named Education ProPolar aims to create educational materials to schools. Profession Polar Scientist was developed in a strong collaboration with HAPEX Portugal and PEI and HAPEX International during the International Polar Weeks. It was a 1-year project, and during this time we had the collaboration. We had collaboration with 11 countries, and we reached more than 20,000 students, almost 400 teachers, and 27 scientists in different events. Education ProPolar was also a 1-year project, and we developed diversified activities over the polar regions and polar science. This image show a pamphlet about polar science and its importance. This pamphlet was created to teachers, and here teachers can find activities by school year and subject. And all these activities can be assessed by the link provided here on Portal Polar. Other activity that we developed was short videos about polar regions and polar science. And we have now 7 short videos about penguins, seals, logistic, drones, and the future of Antarctica. But we want to produce more. All these short videos are in Portuguese, but these videos have English subtitles, so you can use it if you want and if you get to these videos to your classroom. They are all in YouTube, and you can access by Education Popular panel. I'd like to show a little bit. I don't know if we have some time, but it's just 1 minute. Let's see.
Patricia, I don't think we can hear the sound, but probably can tell everyone that most of the videos have sound and you'll be able to access them.
Oh, sorry. Okay, thank you for the
No problem.
information, because I can do everything. Okay, you can access by YouTube and see these little videos. Is only 1 minute or two, and this could be the start of an activity and the motivation to discuss
Great.
something. Okay, other activity that we have developed, it was a teacher workshop on polar science, and this workshop has the same structure of PEI workshops. It has a part of science plus educational activities. The next one will be in March 2016, and we hope that will be so successful as the last one. Another interesting activity that we had developed with a strong collaboration with Apex Portugal, it was a context for students about polar issues, and in this context contest the students need to produce message about polar regions and issues and the global effects, and at the same time drawing attention to changes in human behavior. This was a very interesting activity, and because that this contest became an object of research, and I hope as soon as possible we have a scientific paper about it. And now I'm working on this project, the Irresistible project. That is a European project that pretends to engage youth with responsible research and innovation. And the goal of this project is to design activities to apply in classrooms that foster the involvement of students and public in responsible research and innovation. There are 10 countries taking part in the project, and the Portuguese team chose polar science as a cutting-edge team to explore. So we have developed a model about polar science to apply in classroom context that have this title, Evaluates Earth's Health Through Polar Regions. And this model is for high school level, because inside the students need to analyze scientific papers, most of them related to the theme of our webinar today. And after they analyze these scientific papers, they also need to verify if the research represented in the scientific paper have the 6 dimension of the responsible research and innovation. And as a final product from the model, the students have to build an interactive exhibition about polar science and responsible research and innovation. This was already tested in Portuguese school, as you can see by the photos. And this year will be tested in other countries and also in the other Portuguese schools. This was a very special moment because the students have the opportunity to explain and to share their knowledge about something new to them. And they felt very proud of it and exceed their expectations totally. This year, some months ago, I have also the opportunity to went to Antarctica, taking part in a geological campaign as part of the team of GeoPerm project. And I have to thank to Pedro Ferreira for inviting me to participate in this project. And this was a great opportunity, not only for doing research, but also for doing education and outreach activities. I went as a geologist, but my educator was present in an intrinsic way. And I could saw the impact of having an educator taking part in a scientific campaign. So plus on geological field work, I did the Skype calls with Portuguese schools. Usually I wake up to 5 a.m. to start my day in this cool way. I gave also pre and post campaign lectures. I still giving these lectures today, and in total these activities reach more than 1,000 students and almost 50 teachers. In addition to these school activities, I developed a personal blog that I've started before the campaign and is still active. The posts in the blog are all bilingual, Portuguese and English. And in the first 2 months, the blog had more than 800 views from 23 countries. Associated to the blog, I have a Facebook page with almost 700 followers, where some of the posts have reached almost 2,000 people. This was a big surprise for me. I never expect these numbers, and it was a shock for me. And sometimes I can't believe in what is happening. In the meantime, there was several news in local and national newspapers, magazines, and radio, and also a report on one of the largest channels of the Portuguese TV. This opportunity enabled me to talk about science, about my scientific project, but also to spread the importance of polar science and polar regions and promote the debate about them. This was very, very important for me. And the results show how important it is to include education and outreach activities in research projects in a more systematic way, and the importance to involve educators in it. And now coming to the today big goal, I present two activities that could be done in classrooms about what will happen to penguins and other Antarctic animals, showing evidence of climate change in Antarctic from a marine perspective. So the first one is the Jenga food web. This is a common game that can be found in a toy store, and in this game, students will act as if they are predator species or as if they were fishermen and will interact in the food chain represented by the Jenga game. This activity aims to understand the complexity of the Antarctic food web and also understand the importance of some species in the food chain, and able us to discuss what kind of impact can occur in the Antarctic marine ecosystems. To play the Jenga food web, we need around 30 minutes. It's an easy game, and we need a Jenga game per group of students. First of all, we need to build the Jenga tower to represent the Antarctic food web. And each student should remove a single Jenga piece with only one finger and put it on the top of the pile. Each piece of Jenga represents a species removed from the Antarctic food web, either by overfishing or climate change. As the time goes by, the tower becomes more fragile until the moment that collapses. This is the end of the game and corresponds also to the moment of the food web also collapse. So this activity allows us to explore the concept of food web and to show the importance of each species in the Antarctic ecosystem. And at the same time, allow us to explain what will happen to the ecosystem when the balance is compromised. This activity and the next one will be in the docs in the next weeks in the area of discussion, so we you could read and see if you understand or have questions or another ideas. The other activity that I present is fishing for krill, and in this activity about competitive fishing and choose the most appropriate strategies. The activity aims to discuss about the ecological and anthropogenic impacts in Antarctic marine ecosystems and allow us to discuss the importance of agreements and treaties as the Antarctic Treaty. Fishing for krill is a little longer than the first one that I present, the Jenga food web, and we need also more material. For each group, we need one aluminum pie that simulates our Antarctic Ocean, 12 goldfish crackers for each ocean, and a little more for heading to the oceans. Plastic spoons that are our fishing nets, and direction cards that we find in the rules. The goldfishes represent the krill that exist in the Antarctic ecosystem. So each group have their own Antarctic Ocean, and the student will fish krill. So each student need to choose a country for which they will be fishing to feed its population, and there will be 4 fishing trips of 15 seconds each one. The first fishing trips occurs without any explanation, and after 15 seconds, you see that most of the groups will extinct their oceans. After that, well, we explain if we fish all the krill, the ocean become extinct. And we need also to explain all the rules and give a second opportunity to all the groups to play the game again. But before the second round, we need to give us a few minutes to students for talking about strategies and for students to find the best strategies to the next fishing trip. So in the second trip, the second trip occurs with the rules explanation already, and at the end of the 15 seconds, there will be different scenarios, and we can now discuss about the strategies that each group defined, and try to find if there was any agreements or treaties between students or between the countries that they represent. And this is the moment to introduce and explore the Antarctic Treaty and present to students this great agreement. At the third trip, we will add cards with distinct information to some of the groups. For example, we could say to one of the groups that there was an increase in harvesters, so we need to remove 2 krill from the ocean. And at the end of this trip, we could discuss about the changes and if the strategies or agreements was affected by the information given by the cards. The last one, the students will play the game once more, and we could see which oceans recover the best and which are the most successful strategies, and talk a little bit about that and about other things like if it is important to have organizations that protect the Antarctic or the agreements between countries. So this activity allows us to explain how some issues could compromise the Antarctic marine ecosystems and to show the importance of treaties and agreements between countries, and also allow us to discuss the importance of successful strategies to protect Antarctic marine ecosystems. And as José have referred, CAMLAR is one of the organizations that protect the Antarctic marine ecosystem, and he explained very well how CAMLAR do that. So looking through all these activities and for the results, I think that science and education need to increase and strengthen their collaborations, and PEI is an excellent example of how this could be done. And I think education will play a more important role in the future in promoting and creating a more aware and active society in global environmental issues, and not only on polar issues. And we really need a more aware and active society. And thank you to you all. Thank you, José, for everything, and Luis and Betty and all PEI members to contribute to this great organization.
Thank you, Patricia. We really appreciate both you and
Thank you,
José.
Patricia.
You both have given us a lot to think about, and we hope everybody, all of the participants tonight, will join us Wednesday for the discussion. You can start signing in tomorrow, and the discussion will officially start on Wednesday after other people have a chance to watch the archived presentation. I'm going to just show a couple last slides just to give you some places to look for resources.
Okay, great.
Can you see my screen?
Yeah.
Yep.
Great. Okay. So the resources that Patricia talked about, the activities will be uploaded into the online discussion so you can download them and use them. And that website is polareducator.org/members. And then also here is the link to the videos that Patricia had mentioned. And then, like Jose said, there is sound to those if you upload those. And just a few reminders. Join our discussion and log into the members area. The discussion forum is going to officially begin on October 28th and end on the 11th. To earn the PEI Certificate of Participation, and that shows the hours involved in taking part in the webinar and the discussion, you can see the detailed syllabus on the website, and it involves taking part in the discussion forum, listening to this webinar like you did, and completing pre and post surveys. Future master classes we're excited about. In February, Dr. Jennifer Francis from Rutgers University will be talking about wild weather and climate change. The exact date will be announced later, and then in fall 2016 we'll be having another one, so we hope you can join us then. Thank you all for taking part in tonight's masterclass series. We will post the questions on the website, and Jose and Patricia can help answer those. And again, thank you so much, Jose and Patricia, for being here tonight, and to the working groups for the website and the masterclass that are working groups through Polar Educators International. And all of you are welcome to join Polar Educators International and help us with the working groups, because to help further the vision of PEI and this international organization. Thank you, everybody, and see you next time.
Thank you, Louise. Thank you, PI.
Thank you. Bye, Jose. Bye, Patricia.
Bye, bye. Thank you.
Louise, do you want to stop the recording?
Yes. I think I just, I don't know, Betsy, can you check and see if it's stopped, and then you can.
I got it stopped.
Okay, thanks. Bye, everybody. Thank you.
Hey, Louise,
Yes.
who's going to stop the recording? Because then they'll have the access to the.
I have it.
Betsy
Okay.
did.
Okay.
Yeah.
Mike.
And I'll start working on it right now.
Okay. Thanks, everybody. Went really
Okay.
well.
Cool.
Bye-bye.
Bye.
I'm not gonna...